Alright, so let's take a look at problem number 1. In problem number 1, it gives us the following scenario. So it says that each school van can hold 6 students. If there are 42 students going on a field trip, how many vans will be needed? Set up an equation and solve it showing all work. Okay. So, before I start doing anything else, where I usually try to begin with my equations is, what am I looking for, and let's define that as our variable. Okay? So what's this question asking us to find? What do we know? Caitlin, how many vans we're going to need? Okay, so we're going to pick a variable to represent the number of vans. And now sometimes I'm going to tell you, you need to be somewhat specific. Alright, I'm going to give you a perfect example. Yesterday, I gave an assessment to my Algebra 1 class. And some students say, number of tickets, and some students say the cost of tickets. Those are two completely different things. And others of them just said tickets. I need you to be specific, because when it comes to something like this, we want to know specifically what we're looking for. So, I'm going to go ahead and choose the variable of v. Alright? And what v represents in this problem is the number of vans. Okay, and again, that's not a hashtag. That's well before Twitter and social media. That was a number symbol. That's a number symbol. Okay? Now, we know that we need to take a certain number of vans, but we know that for every van we take, how many more students are we able to take with us? We're able to take 6 more. So every time I add a v into this equation, I'm ultimately adding in a total of 6 students. Now, instead of adding together a bunch of v's, what's another way to show adding the same thing over and over and over again? Multiplication. This is a multiplication problem. Okay? We are going to take the number of vans that we are taking, and we need to multiply it by what? We need to multiply it by 6. Why 6? Because 6 is the number that we'd be adding every time we add a van. So, we're going to begin with 6 times v. Why? Because again, ultimately what we're going to do is we're going to add 6 together v times. Okay? If you were to add 6 together 5 times, you would just take 6 times 5. If you were to take 6 and add it together 10 times, you would just take 6 times 10. That's all that multiplication is. We're taking 6 and we're adding it together v times, so that's represented as 6v. Now, this is how many students we can take with the vans. Well, how many students do we want to take? 42. We want to take 42. So we need 6 times v to be equal to 42. Okay? So when I say I want you to write an equation, some of you might already know the answer 7. That's great. But you need to be able to write the equation that models that. So this is our equation. 6 times v is equal to 42. Okay? Kane, how do we undo multiplication? With division. So I need to divide each side, Megan, by what?
6.
I need to divide by 6. And again, we emphasized this yesterday. We're going to talk about it again more today. We take 6 divided by 6, which is 1. So there's technically a 1, but I'm not physically going to write it there. 1v is just the same as v. So I have v equals, and on the other side we're taking computational work. 42 divided by 6 is 7. So at the end of the day here, in order to take 42 total students on the field trip, we are going to need a total of 7 vans. Okay? Alright, now this was an equation that had multiplication, and we set up and solved it. So unfortunately, as I walked around, I saw a lot of students that said, okay, this is somehow a division problem. Not the case. This is actually a problem that goes back to what we did a couple days ago. So, during a weekend sale, a local car dealership sold 56 cars. If there are still 124 cars on the lot, how many cars did they start the weekend with? Set up and solve an equation showing all work. Again, let's begin with this idea. What are we looking for? And don't just tell me the number of cars, because the number of cars could be represented in a lot of different ways. We're looking for
The number of cars they started off at the beginning.
All right, so the number of cars they started with on the weekend. Let's go ahead and let that be C. Okay, the number of cars to start the weekend. We already know how many cars they sold. We already know how many cars they have left. I'm specifically looking for how many cars did they start with. Okay? So, we did this a couple days ago, and I think it's easier if we have like an addition and subtraction problem to kind of do this, but in my mind, here's what I'm thinking about doing. We are starting with a certain number of cars. Okay, so cars started with. Now, we're starting with a certain amount of cars, and what did we do over the weekend? We sold them, which means are we adding or subtracting from this total? We are subtracting. When you sell cars that are leaving the lot, that subtracts from that. So we're going to subtract from this our cars sold. Now, when I take the cars I started with and I subtract the cars I sold, I should be left with the cars that I have left. So if this is my verbal description, this is how I would explain to somebody how to do this, we now should have a variable or a number that goes in for each of these. Okay? So, what is the cars that we started with?
C.
It's C, because that's what we defined it as. How many cars we started with is C. From C, we are subtracting the number of cars we sold, which was what? Which was 56. And as a result, this is equal to the number of cars that were left, which is a total of 124. All right, Bryce, what's the operation happening to my variable?
First, simply.
Are you adding, subtracting, multiplying, or dividing with C as it's shown right there?
Well, at first you would be subtracting, but since we...
No. That's all I need. We're subtracting. That's it. Monica, how do we undo subtraction? We have to add. Delaney, what do we need to add to both sides here? We need to add 56 to both sides. So I add 56 here, and I add 56 here. Now why? Because again, on the left-hand side, we're going to combine all of these together. What's negative 56 plus 56? 0. So what am I left with on that left-hand side? C. I'm left with C. And on the other side, I'm going to take 124 and I'm going to add 56 and I'm going to get 180. Now, some people, and again, this is practice, this is why we do it, but I want to show some errors that I saw as I walked around. Some people tried to do this. Okay, I saw this out of several of us. There was 2 errors that I saw. Number 1, some people said, I want to add 56 here and I want to add 56 here. Well, here's the issue. What's 56 plus 56? 112. These aren't going to cancel each other out. Now you might say, well, Mr. Tompkins, you said to undo subtraction with addition. Yes, but you've got to pay attention to the sign that's in front of the number or variable. This is a positive 56. So if you're going to move that to the other side, what do you actually need to do? You would actually need to subtract that. Now, here's the other issue. Even if you subtracted 56 from both sides, what do you have left over here?
C.
No. You're left with a negative C. Because the sign that's in front of the variable goes with it. And there's a negative in front of that. So even if you did know to subtract 56, what I want to point out is that doesn't leave you with C. It leaves you with a negative C. Okay? Make sure that you're paying attention to the signs that are in front of the number and variable. That's how you're going to get rid of those. Okay? If you were to solve this equation correctly, the answer actually turns out to be equal to a negative 68. Which doesn't make sense. You can't start the weekend with a negative 68 cars. Okay? All right. Now, let's take a look at the homework assignment from the weekend. Or not the weekend, sorry, the cars were on the weekend. This is from last night. Alright, and again, I'm going to read through the story problems. I will actually go ahead and copy down the equation and everything else that you should have, so you can see those a little bit more clearly as we go. Number 1. Again, this is just fill in the blank vocabulary terms from what we talked about the other day. Multiplication and blank are inverse operations. That answer is division. Okay? Number 3, solve the equation. And again, we must show appropriate work. Tomorrow, when you take your assessment, which will be tomorrow during 7th period, you need to show all proper work. And I will tell you that all of these, add, subtract, multiply, divide, will be on there. Okay? We're not going to test on addition and subtraction and then test on multiplication and division, because there's not enough to test on. We got to throw all of that in together with this standard to wrap up the week. Number 3, C should be equal to a -3. In number 5, U should be equal to 24. Now, number 7, ultimately the question said this: we have 40 black and white pages to print. And we have 20 color pictures to print. The question is how long is it going to take to print both documents? So again, in example number 7, they do a really good job of breaking down what you need to do. Okay? So in 7a to begin with, it says, write and solve an equation to find the time that it takes to print a black and white document. Okay? So, I'm going to let x equal the amount of time. Now, what do we know about the printers? How many pages do they print in black and white per minute? 8 of them. Okay? So, if I print for 1 minute, I'm going to print 8 pages. 2 minutes is 16 pages. 3 minutes is 24 pages. Ultimately, what we're doing is we're taking 8, multiplying it by the time, and that's going to tell you how many pages you printed. Now, how many pages do we want to print in this document? 40. We want to print 40 of them. All right? Evan, what's the operation happening to my variable right now? Multiplication. Delaney, how do we undo multiplication? Divide. With division. So, Chloe, what do we divide each side by? We divide each side by 8. So we divide by 8, divide by 8. So 8 divided by 8, that gives me the 1 that I need, my 1x. And on the other side, we take 40 divided by 8, and we're left with 5. So what does this tell us? It's going to take 5 minutes to print that black and white document. Now, the second document is in color. Now, the printer prints slower in color, because that's usually what happens. And we don't need as many pages. So, how long is it going to take to print a 20-page document? Well, let's begin with this again. Define a variable. I'm going to use a different one. I'm going to use y. And again, I'm going to let y represent our time. How many pages does this printer print in color every minute? 5. So, 5 pages every minute. That's 5 times y. And I want this to equal the total, which was 20 pages. Hayden, what's happening to my variable here? Multiplication. Abby, how do I undo multiplication? Jaquan, what do I divide by? Divide by 5. So when I take 5 divided by 5, that gives me the 1 that I need again. So I have a 1y. And on the other side, we'd have 20 divided by 5, which is 4. So now, part 3 says, how long is it going to take to print both documents? Well, the first one took 5 minutes. The second one took 4 minutes. So overall, this is going to take a total of 9 minutes. That's letter C. All right. Number 9. The answer should be 13. Number 11 is -4. Number 13 is -24. Number 15 is -77. Number 17 is 19. Number 19 is 7. Number 21 is 289. Number 23 is a 3,348. And finally, number 25, find the time that it takes to the drill to melt. The answer would be 5 minutes. Now I am going to tell you this, 25 didn't technically tell you to write an equation. On your assessments, it will specifically say, write and solve an equation to model each situation and then solve. Alright, so let's take a look. Questions that we've got. Chloe, number 11. In number 11, we have that 84 is equal to negative 21 times v. Emma, when we look at that equation, what's the operation that's implied to be happening between your variable and your number? Are negative 21, are those being added, subtracted, multiplied, or divided in that problem?
Subtracted.
Do you see a subtraction sign in between those two? Okay, do you see, let's start with this, do you see an operation between the negative 21 and the v?
No.
Okay, so, if you don't see an operation, what's the implied operation? It's always got to be multiplication. If you don't see the operation between the number and the variable, it's always implied to be multiplication. Brown, how do we undo multiplication? Division. Miles, what do we need to divide each side by?
21.
Negative 21. We got to make sure that that's a negative, because if we don't divide by the negative is going to stay on there, and we can't have that in the final answer. So if I take 84 and I divide by negative 21, that's going to give us a negative 4. And on this side, when I take negative 21 divided by negative 21, that gives me 1. So I'd have my 1v. So v needs to be equal to a negative 4. Okay, Quentin.
23.
Which one?
23.
23. So in problem number 23, we have that n divided by 62 is equal to a negative 54. Alright, Jacinthia, what is the operation happening to your variable? It's being divided. Quentin, how do we undo division? Okay, Chloe, what do we multiply both sides by? By 62, because that's what's happening to the variable. Some people are like, why don't we multiply by negative 54? Because it's not being divided by negative 54, it's being divided by 62. So we need to multiply both sides by 62. Again, over here, we're taking 62 divided by 62, which is going to be 1. So I have 1n here. Okay? And on the other side, this is why I always tell you, use your calculator. This is a computational problem. Negative 3,348. Okay? I'm going to tell you right now, because you get to use your calculators, I'm not worried about your answers coming out nice or being super easy for us to be able to do. I don't care if these turn out to be decimals. You have a calculator, and my expectation is you're using it to help you find your answers. Alright, what is our next question on the homework? Quan. Okay, number 21. Now 21's a little tricky because a lot of times people think that this answer should just be 1. Because they see 17 and 17, they see division, they're like, 17 divided by 17 is 1. Well, that's not right. Caitlin, what's the operation happening to my variable? Division. Kane, how do we undo division?
Multiplication.
Alright, Megan, what do we need to multiply both sides by?
17.
By 17. So, on the left side, I'm actually not dividing 17 and 17, I'm multiplying 17 and 17, which should give me a total of 289. And over on this side, now I am dividing 17 by 17 here, which is what? Which is 1. So that's where I get my 1d from. D should equal 289. Alright, next question that we've got. One. Okay, number 19. It says 301 is equal to 43s. Bryce, what is the operation that's right now happening to your variable?
Oh. Multiplication.
Multiplication. Monica, how do we undo multiplication? Division. Evan, what do we divide each side by? Quentin, is the bell getting ready to ring or what? So why are we packed up? Divide by 43. Again, computational work. Take 301 divided by 43, we should get 7. Over here, when I take 43 divided by 43, that is 1. So I have 1s. And again, you can physically put the 1 there, but you don't need to get rid of it. It's there. That's what you want it to be. We don't write it because it's just extra writing. But when I say s, we're talking about 1s. All right. Next one that we've got. Okay, then on the back of it, on the bottom of it, wherever, here are some additional ones I want you to grab to work through. Okay? We'll go with m plus 14 is equal to a negative 32. And again, you should be able to check every one of those answers real quickly on your calculator by confirming that that's the answer that you get out when you plug that answer into the equation. See, a lot of us that could benefit by checking our answer. Computational work is getting us, I'm telling you right now, ladies and gentlemen. And we're refusing to check answers, so we just assume it's right. All right, here, I want to get through these 4 before the end of it. So, I'm trying to think where we left off at. I think I left off with Evan on the last one. So, Delaney, what's happening to my variable of m?
Addition.
we're adding. Chloe, how do I undo addition? Okay, Hayden, what do I need to subtract? 14. So subtract 14 here, subtract 14 here. Now again, why do I do that? Because what's 14 minus 14? 0. And so what am I left with over here? I'm left with just an M. On this side, negative 32 minus 14 is a negative 46. Okay, and again, computational, you have to plug that in and be able to do that. Abby, number 2, what's happening to my variable? Division. Jaquan, how do I undo division? Okay, Rollin, what do I need to multiply both sides by?
4.
By 4. So, multiplying by 4 over here, this is 4 divided by 4, which is 1, so I have 1x, and over here, 8 times 4 gives us 32. Number 3 is a biggie. Did not see a whole lot of correct answers and correct work that went with this. Because we're not focused on the sign in front. What do we need to get rid of that's with the y right now? A negative 13. So if I have a negative 13, I need to add 13. Some people again are like, well, but this is a plus, I need to do this with a minus. What happens if I were to take negative 13 and subtract 13? I don't get 0. So, I need to, because this is a negative 13, I need to add 13 here, which means add 13 here. 42 plus 13 is 55. Negative 13 plus 13 is? No. 0, so I'm left with y. And if you're confused about this, did we say that the order of addition matters? No, I can flip it around, right? So if I can flip this around, couldn't I write this as that? Now, what would you do to solve for y? You'd add 13. Look at what we did. We added 13. You got to pay attention to the sign that's in front of the number or the variable, okay? Emma, what is the implied operation right now happening between my negative 3 and my x? Multiplication. Miles, how do I undo multiplication?
Division.
Quentin, what do I divide by? Okay, negative 3. Not just 3, but negative 3 to get rid of that. Negative 18 divided by negative 3 is a positive 6. Negative 3 divided by negative 3 is 1, so I have 1x. So x should be equal to 6 in this problem. Alright, we will start 7th period, with some more of these problems.